Good. So I'd like to welcome everyone to this little training session. I've made some assumptions about the participants. I just want to see if that roughly fits. So this is tailored for the audience that responded to the survey. So I've got some information for lecturers in software engineering and education, and some for IT and some for safety engineers. I'm just going to start sharing my screen so you can see what I'm looking at, and then I'm going to direct you to the repository so you can follow along. Can people see what I'm sharing? Can I have some feedback, please?
Nice and clear.
Very good. Okay, so as you can see, and I'm going to paste this into the chat so you can put your fingers on it yourselves. This is the address of the repository that I'm going to present from, and you'll find all the materials that you see in there, including outgoing links. So everything you'll find in either this repository or in the wiki that belongs with it. In fact, I'm going to be mostly presenting out of the wiki. Good. So just a small overview of what I'm going to do. I'm going to give the overview talk, given that I've presented previously, but only in 10 minutes, and it probably merits a little bit more than that. So I'm giving myself 20 minutes. Yes, exactly. Thanks, Nuno. Please raise your hand if you've got any questions, or just type into the chat, and I've got my eye on that as well. Then I want to go through, so people have provided me with points of interest. The 3 points of interest that were raised were to see some real world uses and applications of MDE and Epsilon combined with DevOps. And you see on the right-hand side, you see the use cases that I'm going to talk about: integration with GitLab, building an ASP.NET application, some GitOps, quality documentation, security, and workflows. Somebody raised the question of how Epsilon can be integrated with Sirius and other Eclipse and non-Eclipse tools. So I've got a section on that. And then one question was, are there any pain points with Epsilon-CI? So I've got that here. If you want to skip ahead, the links are here, so you can already snoop and prepare yourself for the point. So that's the plan. Now, does anybody have any comments? Would you like any different directions? So I've made some assumptions about what you will be able to do technically. And if I throw you off because these assumptions are wrong, then you need to stick your hand up. There's going to be a lot of technical stuff in this talk, necessarily. Okay, are we good then? Good. Then let me just start with the overview talk, and stop me if I get to missioning in some respects. Okay. So the framework that I'm going to present, or the tool that I'm going to present, has been dubbed BB8. That's because the company that I've been working with in the past was building what they called software bots, which are code generation tools largely. And they were tailoring them so we were tailoring them so the customers were able to design the process themselves and control it, which implied DevOps. Okay, here are a few examples. Those are the use cases that I'll go over with you later: generating full stack applications, doing some certifications, doing enterprise application modeling, maybe some MBSE, DevOps with GitLabs, Helm, and provenance checking. Okay, the next ones I will keep very brief. Can anybody please, anybody who does not have hands-on experience with CI or DevOps, please type a short remark into the chat to see if I need these next slides, because otherwise I'm going to skip them myself. Yes, I'm referring to model-based systems engineering. Model-based systems engineering. Otherwise, I would use MDE probably this term. Okay, so we've got one person. Thomas, to quickly explain continuous integration, basically it revolves around the concept of having a version control server that acts back. So at the moment that you send a change of your project to the version control server, the version control server detects that and then follows a recipe that you have also put in there, effectively a build script, to carry out the instructions to make your project. So that is generally a beneficial practice insofar that it takes it away from each person building their own stuff locally and then with a corresponding reliance on the local dependencies. It means that you can repeat your process because you're formally writing it down. So there is no manual interference, and you hence gain greater repeatable quality. It's also a repeatable software process in terms of the formal SEI definition with that. Basically, these CI systems replicate what you can usually see in the instructions of a manually written project. There's usually a description of how to set up your computer. Then there is a description of how to download the software files that you want to compile, instructions that you type on the command line, how to save and preserve the result that you produce, and potentially, if you have multiple steps, then you hand that on. So, and this typical pattern that you can read in instructions is then done on the server. Now, this big step, setting up the computer, is something that is relatively slow and tedious. Fortunately, we now have containers. Containers allow you to completely isolate a computer system and describe how it is set up. So you can say, I would like a computer set up with a JDK, and it has a certain URL. The computer is then downloaded. You enter it via a special command. You get a shell in it, a shell command, and then you start typing your commands. CI systems do that very thing. They have a description of all the computer installations that are involved in a build and all the instructions as they pertain to them. We'll see how that looks later on. But basically, that's what it does, and GitLab is one of the purest forms of that. Here you see one of these. So this is potentially the first computer with the first set of instructions. Then there's potentially a different one, two in parallel, in fact, running, doing test jobs. Then there's post steps. And here are some additional things where other projects are then being triggered. As a queue, as a procedure following through, you can, of course, also type commands in that actually put the thing that you've just compiled into production. That's then the D in CI/CD, continuous deployment. Okay, now let's look at the resources that we are interested in as modelers that might influence us if we mix model-based computation with regular source code oriented computation. So first of all, we need to be able to take in standard reflective formats, EMF, XML, or even untyped formats like JSON and YAML. So we assume that that's possible. Then we want to take in a bunch of modeling tool inputs, and we can do that. So we'll look at that later. That's one of the use cases. We may want to reflect on the contents of storage systems, databases, or languages, so the ability to parse some of these. And finally, we want to exploit at runtime the various modeling technologies that have been built over the years. Okay, So the motivation for this project was that we have Eclipse as a very nice environment and EMF as a very nice modeling component, but both of these are heavily geared towards individual desktop use, and they are very much mouse and click oriented. So they're not actually suitable to be running in a CI loop as I've documented, as I've described it. Now, without the CI loop, we don't actually get the benefits of CI. So we can't actually truthfully use modeling for software engineering because there's a piece missing in the middle. The missing piece that we can use, it's a bit of a kludge because it's old and comparatively ugly, is a build system called MDENet that has been the historical build system for Eclipse and used by Eclipse. And it is still very well supported as part of the Eclipse environment. And that one can actually run what's called headless. So it can run on a command line. There's an application called the AND runner, and it does this. So AND formulates the way it builds in such a way that you have what's called a project. A project has targets, which are a tree of dependencies. You select a target that you want to build, and then all of its prior dependencies are also being built previously. And for each target, a sequence of tasks is executed, and they can be parameterized with attributes. So here you see such a project, name is main, target is also main. There's a JavaC compiler, and that concludes the project. So it's a minimal project. This is the equivalent of such an AND build that uses Epsilon. You see here, there are some tasks that Epsilon has contributed. We're loading an XML model, and then we're looping over a set of XML files in a directory. Each of those is being loaded. We're doing something with it. This is inline EOL program, and then we drop the model afterwards. And that we do for every single one. So here you see a minimal process, and that's the thing we want to actually run. In terms of how this is done, overall, if you as a user commit a file, that sets off GitLab, which then in a container sets off the AND runner, which then creates in MDE task, creates an AND runtime and the MDE task within it, which then goes to start Eclipse, EMF, does all the EMF related operations, and then returns back. That's what happens when you start one of those projects. And, I'm going to switch over to the screen here for the moment so you can see what that looks like. So if I look at the actual pipeline here, you see I've been experimenting. So here you see this is a build file for a merge, and you see what it does. It loads models, compares, merges, disposes, and then we get response messages saying that the build has succeeded. Now, what sort of things can we get out of the AND box? Well, we can get probably 2000 to 2010 vintage operations, including Git, preprocessing, some archive files, documentation generating, mail sending, some coverage tools. It is not difficult to write a task, but because the tool is not so popular, there has not been a whole lot of investment in it. Then these are some tasks that have been contributed. So I've been grabbing over the ATL and Epsilon transactions, Epsilon code base, and have looked at what sort of tasks we can get. So sample generation, essentially all the Epsilon languages and everything that is in the Atlas suite is readily available. Here is the list of tasks. So if you, let's switch to Eclipse here and let's not do that for the moment. Here, you are pesky. If we're looking at the AND runtime, we see under tasks, we see this dialog here, and in it you find that a lot of tasks are installed into Eclipse, including all of Epsilon here. So anything you can contribute these tasks to Eclipse, and then they become available in your runtime. How that is done installation-wise, we will come to later. Here is, as a look ahead, the technology we use. So there is a tool to install bits of Eclipse, where you say what you want to install and where it's being installed from, and where the installation is located. And so you can fill an Eclipse without ever starting it up, just by manipulating it, using it, the installation system called the director. So all of that isn't worth a whole lot if we can't provision the tooling to people's desktops to experiment and try out the scripts. For that, we use oomph. That is a model-based system that allows us to configure Eclipse instances rather easily. And we're going to use that to set up your instances for the test. Sorry. Have I experimented with Gradle? Yes, I have. In fact, how useful would it be to have a Gradle plugin from Epsilon instead of Epsilon and task for Gradle? Well, the problem with Gradle is that Gradle cannot run inside OSGI. That's the great limitation. So my company has designed a runtime around Gradle already. That exists. And the advantage of Gradle is that it's much faster. But the downside is that you leave all the framework bits of Eclipse behind. So you would need to write yourself a version of Gradle that is OSGI friendly. And that was just outside my budget. I couldn't actually do that. And that's why I am reusing the AND infrastructure. The reason I'm doing that is because most of the cost, the computational cost, is not in the invocation system. It is usually in the underlying layers. For example, if you think of parsing, reparsing in terms of merges, that is a major computational cost. Or diffing, that is a major computational cost. Just calling a task is not so expensive, and so I'm accepting AND. The other thing is that Gradle excels at more complex parametric operations, and I would like to target this at people who are basically primarily clickety-click modelers who want to integrate their workflow with an industry workflow downstream. So I can't really have a very complicated system. And Gradle, while it's very flexible, doesn't have a straightforward structure that shows that easily. So those are the points that have influenced me to stick with AND. A large amount of reuse and not so much of a need for the additional features. Is that good, Antonio? Can you speak up so I can hear if I've helped you?
Yes, that's a great answer. Thank you very much. I think it's interesting to just think about the fact that Gradle is less friendly in terms of OSGI compatibility.
Yes, I can't start it. It's not, the launcher will start a new JVM, and its class loader is very proprietary. So it will not allow me to do any of the things that anybody has contributed. And then what do I offer?
Yep, that makes sense. Thanks a lot.
You're welcome. Okay, so there are some limitations, and one of the participants has asked to go through these. So I will do that later on. Okay, so and I'm very, like, I would be very grateful if I could get some assistance to grow this project, because I hope that it's going to have some, will be useful to industry and academia at the same time. So, okay, so that was the introduction. And now let's go to the points of interest. And let's start with the real world applications. So I'm just going to talk about, the applications and the way they're built first, before we come to how the kit works in detail. Pardon me. So the first application here is what I call DevOps with GitLab and GraphQL. And you will see that this theme grows through later. So GitLab, every time you make a ticket or run a build or anything, a background database is exercised to keep that information. So when I look at this pipeline here, the fact that this has passed, what its number was, when it was dispatched, what branch it belongs with, all of that is in a database. There are APIs to this database, a whole number of them, but they are separate and focus on specific topics. So tying them together is a little bit challenging. To get around this, the GitLab design has enlisted a standard called GraphQL, graphical. And you see here, there is what looks like a pattern match. So this is a query in GraphQL or graphical. It queries for a project with this path and then asks to report name, force count, statistics, the size of the wiki, and some other things. Now I'm going to copy this and I'm going to go to an explorer that is built into GitLab. You see this is gitlab.com. And you see the query is already in here because I had it in the cut buffer, and I'm going to run it. Now this is just an HTTP call. So just made an HTTP call based on certain conventions to a certain URL, and I got this YAML response. So now I can formulate queries, and I can retrieve structured data as responses. How do I turn that into a model? Well, it turns out that I don't have to do a whole lot because Epsilon has done this for me. Epsilon's implemented in version 2.3.0 a YAML flavor. So you can read this return value, commit it to disk, just write it as a file, and then read it. And we have this notation. So we've got the curly brace notation. And then you can access this by names. You can go over it and say, I'm looking for a node and its name is project. And then I'm looking for an attribute whose name is name. This allows us to immediately process the result of such a query in a model-driven operation. And that is effectively what we have done. So we have used this query access to write ourselves model-driven tools that validate that the project is in a specific state. So do all tickets have people assigned to them? Are all tickets built within a certain time? How long we would compute things like how long does it take for a certain build to run? Which one are, give me the listing of the 3 most expensive builds and such. Obviously, you don't need to use the reflective form all the time. Once you've got something that is stable as a result of a query, you can write yourself a model and transfer the YAML, load the YAML into the dedicated model, which makes the navigation in the model in EOL and in Epsilon a little bit easier. In order to get the information, you use AND get, which is an operation that does something like this. It downloads from a location, and there is a converse operation that allows you to do a commit on this. So I should note that GraphQL also allows mutations. So you can create, you can get some data, write a mutation function, and alter that data. That means we can write all the fields in GitLab. So for example, we could provision a new project by writing a new project node with a new path, giving it a name, and giving it a description. That would, out of a model-driven process, do a provisioning operation on the CI system. So we can do DevOps on GitLab with models, and they run in processes like these. So that's the first scenario that I wanted to talk about. Is that clear so far? Because it's no use. Can you show an example of this? It's proprietary and it's been left with my company. I can recreate one of that, but what I've done here is to play out the examples that I know of. So if this is of interest, then I'll implement that into the container. It's not complicated. So this is, yes, effectively, yes. So Epsilon is downloading some data from GitLab and then reads and manipulates projects. It can potentially kick off pipelines. It can kick off pipelines because it can send commands via the API. Yes, that's what it does. And you EGL to generate the graphical queries, or do I have, no. No, you've got that correct. So you can use EGL to generate those queries, or you can use FlexMe YAML and write it directly if you don't want, because it's YAML syntax. Yeah, so that's the functionality there. Okay. Let me get an. Reads the YAML from GraphQL via its FlexMe driver. Yes, that is correct. And in reverse, if you were to write the query, you could also make yourself a FlexMe with YAML and write the query using the YAML driver if you didn't want to template character by character. The query isn't YAML or JSON, is it? Yes, it is. It is, if you look at the queries, this is a query. I think that's a JSON format. Yeah, that's the curlies. Yeah. So it is formatted as that, but it needs to conform to the schema of the target system. These terms are specific to the target system. There's now a full YAML driver. Okay, this is even better. Yes, that would make it shorter and less reflective. Yeah. Yes. Good. Let me move on because otherwise I won't be getting through these. So this is the anatomy of us building a full stack application. You find the links to the pieces above. So we start with 3 models that are interlinked: user interface model, entity model, and an action code model. And we validate those. Then usually there is some pre-written code. Thank you. Thank you for dropping that link. Usually there is some pre-written parts of the application where people have written code manually into protected regions. And they need merging. And with that, we generate out of user interface, entity model, and action code, we generate React and HTML for the client component. That is the component we ship to the client from the HTTP server. And we use the entity and action model to create a C#.NET solution, Docker files, and Helm files. We then run the whole thing. So up to this point is model driven. Downstream from this is conventional software development. So now we run it through the requisite compilers. We then package this, package the application using a tool called Canico, which is effectively a Docker build without security issues. We build it and we deploy it to a Docker registry. Then we pull it and run the smoke test on the build application. We use Helm lint a second time to now with a reference to the container to make sure that the Helm instructions all resolve. Then we deploy the Helm to the Helm registry, and then we run a deploy calling the Helm program to a defined Kubernetes host. And as a result, the full server becomes available. Now that's very abbreviated because there are obviously ways where you only develop a developer branch and it will go to a different place. So I used work breakdown structure because it's such a simple model rather than one that is very cluttery. So it's a bit reduced, but in the core, this is what it is. So here above, you see the various components that are going to be used in the build in order at various levels in case you want something like this. There is one project that I'm likely to publish in the next few weeks, which uses a tool called Roo, and that is able to generate a Spring application, a full stack string application from a model directly. So with that, you would generate a Roo specification using EGL, run Roo, and then you have an application. I would like to publish that because I think it's attractive for teaching purposes. It gives you a real Spring application with all the features and fixings based on a model that you put into Epsilon on the left-hand side in just 2 or 3 steps. Okay, good. Any questions on this one? No. Okay. Next one is GitOps. Here, the idea is not so much about building software as it is about deploying software. I don't know. I assume that that there is some familiarity with Helm. If there isn't, then as a brief explanation, Kubernetes gives you a model of a server room. It doesn't actually tell you how to operate that server room, so how to put disks in and how to wire networks up. In order to make those procedures reproducible, there is a template language, and that template language is Helm. It's quite literally, as you can see here, a template language which replaces parameters that have been put into the templates in this form. You see here that a value that is being fed into this Helm template is then piped through a function called quote. Those are template functions, and these are called pipeline operations. They're somewhat functional, like in functional programming or in Unix pipes. The problem with this is generally that the input side of this is not well typed. So you could get anything on this side, and the template's deployment would then fail because something odd comes out. That is the reason why we designed a tool that allowed us to have models that would feed into a specific Helm template. It made sure that the values were consistent, could be validated before they're being fed into a Helm to do the deployment. So as a result, you had a model of the configuration of the application. And as you committed that model, the Helm templating was executed, and then Kubernetes would deploy. And that's exactly GitOps, but it's model-driven GitOps. So the configuration goes through Git in order to get deployed at the end. Once you have such an application model, you also find out what you want to configure about applications. Now, there is usually in Kubernetes, you can turn a computer on and off, and you can stop and start a disk or disconnect the network, things at that level of granularity. That's pretty crude in terms of replacing an application. So Kubernetes has a concept of what's called operators. Operators are special processes that communicate with the applications in the cluster, in the server room itself. They do things like backups, upgrades, change service optimization, think like database parameters, or they can escalate if they see a failure when monitoring parameters in the application don't meet requirements anymore. So now Kubernetes doesn't have the application-specific expression. So the question is, what would you back up and when would you back it up? And that brings you back to a model of the application. It describes this particular application in a user-accessible manner. And then when you commit that model, the operator can take that model configuration in and then maintain the application in the cluster in the way you want. Again, you would commit the model to Git, and the operator would receive the updated model from Git. So it's GitOps again. Okay. Any questions on this one? No.
What do you use for model diff merge?
What do I use for model diff merge? I'm just using the differencing engines that are in Epsilon. I know they're slow, but with the CI processes, often this is not such a great, like there isn't a big speed issue. If the deploy takes a minute longer, that doesn't matter too much. Interactively in Eclipse, you can use the model diff as well. So it's EMF diff. Yeah.
Okay, thanks.
What motivated that question? Can I ask back?
Well, I mean, in any large industrial model-based engineering context, I mean, diff merge is a real issue, right? I've heard several people saying that model base cannot be used because there's no proper diff merge, and diff merge had, I mean, the whole work on EMF compare, for example, was going in this direction. And when we started building DSLs in particular, then if we get a DSL built on top of EMF and we do EMF diff merge, and we get the diff merge at the EMF level, not at the DSL level.
Yeah, so I understand that. So in this case, it's not such a, like in these scenarios, it's not such a big deal because the data is going to be very compact. If you had that issue, the way I usually go at it, if it grows like this, is to run the document through a canonizer. Like I create in an XML form and turn the IDs on. I know the IDs are a pain, but if I turn the IDs on, then it is resilient against reordering. I run it through one of those XML canonization algorithms, both sides, and then I do the compare. And
text-based, right? Yeah.
Yeah, that's how I have to go about it. And the other thing is that people, I believe, are not using resources the way they should. So they dump everything in one large resource, in one large model, when models should be compositional. So then you would more easily see if your thing is different. If you keep the alternate state per resource, you easily see if the resource is different. If you commit them to files, you see them showing up as as different by the hash already. So it's a design question on the way resources are constructed, I would say, for those large files.
Thank you.
Yep. Good. Okay. If there are no more questions, then I'll just move on to this one. So another thing that you often get is you get ISO 9001 or formal different documentation of various kinds that the company wants to maintain. We had that in context of another ISO security and process, so 27001 audit. And that means that you need to connect the company process, what's being done, to a living document. And most of the time, these documents are dead. So we used the approach that I showed for the GitLab interface to drive the generation and regeneration of that formal documentation. That is, whenever anybody changed any wiki that described how a certain process in the company was to be done, things were rerun, and this was caused people to need to accept that we changed our ISO 27001 documentation. That meant that if an auditor came in, they always had an up-to-date document. There wasn't a difference between what the company was practicing internally and what they were producing on the outside. It's just a specialization of that GitLab process that does the downloads and the writing process, a different application, in this case, towards formal documentation stuff. This one I acquired over the last 2 weeks, so there is often a problem finding out what your project is made of. For, as you see, that's the Secure Software Development Framework, SSDF, which will probably become required for many government supplier organizations. So you can write assertions towards how your program is built. Let's see. I'll just pull up the SALSA webpage. So it describes what the security levels are, and it produces a writable form that describes how this particular project is built, whether it's build as controlled, whether it uses pull requests, and so forth. And as you recursively parse these assertions, you can find out how good your underlying quality is, or whether you can be hit by a security problem from below. It's like an explicit version of Black Duck, if you want. Black Duck does analysis, while this one verifies assertions. This is done by an open source project called Macaron that I collaborate with from Oracle Labs. It checks these assertions recursively. And the policies that they have to see what's allowable, so here is a data log expressed policy. They look like this. They're not particularly user-friendly. So what I'm doing with Macaron is designing a model that expresses these policies and allows non-expert users to formulate what level of security and what assertion they would like for their project. Then they can run the checker. Yes, it is, Antonio. It is data log. Data log is a restricted form of Prolog. It has reduced expressiveness and higher performance. It's the basis for the checker that they use. So you write those assertions, but obviously you don't want to scare people with Prolog. So that's why we're going to wrap this in a model so they can configure that nicely. Okay, any questions on this one? No, good. So that was provenance. And now my company has demoed the way it has overhauled its whole process to run based on this idea of GitLab. So we started with that tiny GitLab example. and then went to the QM documentation for our ISO process. And finally, this is now grown into the company using a technique called Judoka, which basically does our whole project control out of models. So within Working Mouse, grown out of CodeBots, when you start a new project, you parameterize a model, and that model creates you your repository, initial documentation, checklist, how to approach the customer, and so forth. And as you go through the project, if it's something that your CI has space for, you simply code it into the CI system. If it's something that's proprietary to the method, your Working Mouse or CodeBots method, then you put it in the model, the CI will run, and all your documents and all your other stuff correspondingly updates. So Judoka method is built on DevOps, model-driven engineering, and CI/CD. Yep. Okay. So that was part 1. That was interfaces with various technologies. Now, the second question was, how do you interface with modeling tools outside, inside and outside the Eclipse sphere? Well, some of it is very easily done already. So you can, Epsilon in the Epsilon Labs has a driver for Cameo and Magic Draw. So those are ticked. I have got a project that, and I'm allowed to use this logo thanks to OMG Ascent that has UML 142 if you just want something small in it. So you can use that model. And then now we're going to look at special cases. So one of the cases that I had to work with was where I needed to do enterprise architecture for a tender using the TOGAF standard. There is an Eclipse RCP application called Archie, and inside it are Eclipse features. And I showed before how I can build Eclipse features into the container. So what I've done is I looked at what features does Archie contain, and then I installed the corresponding models into the container. So the resource factories and the whole thing, that the stuff that reads this bit in. That allowed me to simply read the Archie files. Now they came up as regular models in the EMC or in EMF, and I was able to manipulate them and code generate and validate whatever I wanted to do there. So I could just use this, commit the file, and my TOGAF specific workflow would run. So that's working with Archie with TOGAF. Serious, this is a quote. This below is a quote from their own documentation. You will find it linked. So they're saying Serious assumes that your domain model is defined using EMF. So what Serious does is it produces views on an underlying domain model. The assumption is that all essential information is in the domain model. And we're told here that that's an EMF model. So if it serializes as a regular model, and we can be pretty sure that there is an XMI rendering for it, then we can load that into the tool chain. And again, we're away and can do what we want with it. I have not actually loaded any models in Eclipse into Serious, but that's how I would go about it. And Papyrus is a similar case. It uses Eclipse UML for storage, so you can read it. There's a version that even pushes it into CDO in case you want to work with multiple users on a database. Okay, let me go back. Who was asking for the pain points? Do we want to do those first, or I feel it would probably be better to do that after going through the steps.
That was me. This is Antonio from York. That was me, but I think I would agree that it would be better to go first through, an example you may have before that.
Yeah, that's right. So what I wanted to do, let me see if I can. So let me go over here. So this is the repository. In terms of setting the whole thing up, you need there's a description here. I'll just open it up for you. So in order to install the tooling, where's my, yeah. It's on the main page. You need to download the installer, copy this link, start the installer, and then do apply configuration. That will install for everyone interested a version of Eclipse that is ready to work with this tooling. The way that is done is through a configuration file. So there's this configuration file, and it basically lists all the components that are necessary. These are the components, and these are the repositories that it's drawn from. And then it does some initial deployment for when the Eclipse starts up for the first time. So do you want to do this? I could do this once here for you as a demo. Is that of interest? Do we want to do this? I might do that just now. So while that's happening, while the installer is starting up, okay, now I need to do so copy the link, and then this installer. Where have I left my installer? Oh, there. Okay. So I should have that in here now. Oh, it's restarting to install. Okay. I think this will take too long, takes too much away from our time. So I would like to show you the way that these builds are executed. So this is one of those projects. It's from the Epsilon test suite. So all of these are Epsilon test programs. It's here in the build XML. The name of the project that is being imported is here, so it gets that. Then the corresponding path is discovered, and then the project executes. Now, the way these are all started is via the CI file. And you see here each run is encoded like this. That's the entry point for the program. That's the build file to run, and that's the target to run. So in order to run any of those builds, all you need is this. It will start, so it's an extension of execute a build, which is this here. The dot means this is a template, so this doesn't actually get executed. And it runs this container, which is the Epsilon-CI container itself. How does the CI container get built? Well, we use yes, I did.
All right, yes, you did at the beginning, but I'm thinking, just in case somebody joined.
Yes, thank you. This now has thrown me a little bit because I know I've lost my meeting. There we go. Okay, yes. Thank you for that. So this is where you find the sources. So what you see here is you're saying we're using Eclipse Timoran, so we're using a container that's empty except for Java. Then we know that this is a Debian system, so we install a number of libraries that we need to get Eclipse going, including a simulator for the windowing system in case some library checks for the presence of a windowing system, and we have to simulate that. We then say this is a Linux system, so we need to get the Linux archive. This is the download address. We're now downloading it. We go to the installer directory. We define the places that we're going to download from. You see that I've made myself one site here where I've added some tasks for my own use already. We say what we want to install, which includes the whole of Epsilon. And I needed to work with WSDL for some reason, so I've got WSDL and XML SDK, XSD SDK installed here. And then I install this. There's this Docker entry point, and the Docker entry point is a very simple script that says run Java, run the ARNT runner, run this file with this target, which is what we saw in the other file. It always is target file and target to call. So, and that's how the whole system is assembled together. And once we execute one of these builds, I can just rerun one of them. Rerun one of that. It should be a rerun button somewhere. Yeah. So let's rerun the PetriNet generation. There, we see it's going, it starts up, and then it generates the model for the PetriNet. So that is essentially the way this system is set up, including its capabilities. Now I'll see that I move back to the installation, see that I get that going, so we can import the files and have a look at how we interactively work with it. Okay, any questions so far while I'm looking for the link here? I understand why my installer is shutting down. Maybe my installer is broken. I had tried this before, but maybe I been using an installer that's old. Good, let's start from first beginnings. Let's see if I can. Aha. Now that looks better. Apply configuration. There we go. Switch to advanced mode. Yes, that's fair. Let's call it that. Install it. There we go. Do you have pipelines where the generated code one feeds into the next job? How do you manage the evolution of the generated artifacts and relate them against their source models? So yes, those pipelines are, occur frequently. So that's the normal case, actually. Whenever you have EGL, you create an artifact. So there's an artifact construct that moves the source code to the next stage. The relation to the source models is not usually done. It's forward engineering only. So if you have a protected region, then there is a chance of breakage. So you either need to model your code, model the things in forward generate, or you need to accept that things will break and your tests will show you. Or the third part is to parse source code. That one I usually do not recommend because it's very tedious and effectively it makes the model equivalent to the code, giving it too much detail. So I think the protected regions, together with some checks, runtime checks and tests, are probably the best way to go. Does it help, Antonio? Yep. Okay. Sorry about the slow install. I had actually installed the application beforehand, but I must have made a change somewhere underlying. On the other hand, you can see that this is working, and you can do that yourself if you want. Let me just go back. So maybe I'll go now, while that installation runs through, go to this particular area where I'm addressing some of the items that we found to be challenging, or I found to be challenging. So I've already talked about canonical representation. One of the items that we found to be difficult was the formatting. So the formatter. When we write source code, using a diff on source code is beneficial. For that, you have to have a canonical representation. If there is no formatter, you can't achieve that representation. And so diffing becomes challenging. Epsilon languages don't have a formatter. There is a reprinter, but it strips comments out. So that would be one of the things that would be useful. Another thing that we found challenging in Epsilon is the way components are addressed. So in Epsilon, everything is a module. So you include modules, and the include is via URL. There isn't really a convention as to how these modules should be addressed or named and what URLs you ought to use. So it would be great if there was some guidance. We've used Java-based notation in the end because it's so Java associated, but maybe something else is better. I just don't know. Similar for the layout of files in a project. Where should they go? Should each type of Epsilon language go in its own package, or should they all be mixed and just in the same package structure? What's better? I haven't seen examples that are covering a project of this size. Scaffolding is another thing. So all the other frameworks have like npx create, Maven archetype, Gradle init, Spring initializer, and so forth. There's nothing that says, oh, set up an Epsilon project so we can do multiple steps of computation here. And another thing is, if you put a project together and it has multiple levels and does complex things, then obviously you would want to know what it's currently doing. There isn't good logging available in Epsilon. Most of it goes via standard out logging. So that's also connected with this component addressing, because you would need to know where the logging output actually comes from. What's the name of that module canonically that you're looking at? And then there are a number of interoperability features that are required. Okay, now let's hope that this goes up in a moment. Yeah. And finally, you saw that I used the P2 installer to create this container, and Epsilon is defined as an oomph project, which is what we just used to set up. But there isn't an easy way to run oomph inside a container. Oomph is the Eclipse installer, and it has a user interface. So that makes building the container complicated, because you have to try out and find out which features are actually useful for it. So it would be good for Epsilon RCP to have a P2 based product that shows that clearly. Okay. Okay. So Let's go and clone the project. I think my computer is weighed down with the load of projecting with Teams. And try this one more time. So you see here, I've got Epsilon, CDO, and some Docker components in as well. So clone, there we go. Okay, finally. And we just want main. Using a new one. Demo. So and then we're going to import this. First demo. So here is the project, and here are the sub-projects. And if we go and we go in here, and we run this, and there we go. So here is the build. So we're loading the family eco model. We're loading an instance of the model, which is the Smiths. And then we run this program, which prints name of the first family, the Smiths. And when we look at this, the HUTN example in our execution here, do I have that? There we go. It gets executed in the very same way. And that shows you can download this container, do your applications in here, and then perform the execution on the server. So anything you can do with Epsilon, you can now do with Epsilon in the DevOps system. Okay, happy to take questions at this time. Sorry about the enormous wait during this installation. Is the container available? Yes, it is. Yeah, so its address its address is, there has to be, otherwise you can't operate with it. So let me unhide this. So its name is here, and its location is here. It's in the package registry of the project itself. Oh, hang on, container registry, sorry. In the container registry. So this is the container here. And you can use that straight away. So if you reference it, yes, others can use it without cloning. That's the point of it, of course. You just pointed it from anywhere you need to. This project is just written in this way because I wanted a smoke test. So I wanted the Docker file, which creates the container, and then GitLab. So here you see the container being built. We're using Canico, and then we build Docker file and we push it to our own registry. What is the cost benefit trade-off in more realistic projects? So my point of view is
I guess how large, how large and complex does your workflow need to get so that the added effort of all of these, of managing all of these various additional plugins and tools that you have to install, etc., becomes sort of worth the benefit, if you see what I mean.
So, I mean, when you saw the installation going through, you saw that I had to do two things: download the installer and paste the URL, and then I had this IDE, and from that on, all I needed to do is write these files. So write a file that has this template in it. I don't need anything in addition to do that. The question about what's the feasibility? Well, anytime you want to use a model, because complexity reaches a certain point, then this makes sense from my perspective. And from the applications that I've shown there, the complexity on the model side is significant. So it's a difficult question to answer. If you're more, if you believe that you've got it all in hand doing code, then that would be, then do that. That's probably what I would say. I find models beneficial to express complex contexts. So in terms of the full stack application, they can be built using this approach, and they are significantly larger than this. I'll see if I can find the RU demo. Equal to RU. So this is a tool that generates the RU output files. Now I'm not sure if that is running, but you see here that it generates the descriptor for the RU language, and after that you have a full stack application. So from that perspective, I think the cost benefit is relevant. Maybe used to tag it based on an agent. Yes. So if you look at my this regarding the tagging, the question that it may be useful to tag the container based on a version. I absolutely agree. You will find if you look at the at my wish list down here, roadmap. Proper versioning plan. I know that sounds academic. So it's I need to figure out what the best schema is to version this properly, because there are several dimensions in which this moves, what it's being built with and such. So,
yes, I was going to say that, for instance, even my practice with Docker containers has also been to have even scheduled jobs. So rebuilding Docker images, even when nothing has changed in your definition, because you might have upstream changes, right? The temporary people might have decided to upgrade the Java version and all these things, right?
Yes, yes. So, I mean, I usually go for, if I say latest, I usually mean a brutal latest. So you don't actually get a lot of guarantees. If you want something that is definitive, then you quickly end up with a matrix build saying Tumurin 2.4 with Epsilon 2.4, Tumurin 2.4 with Epsilon 2.5. There are ways to do this. But often you want to restrict that, because if people need specific versions like this, they can basically take the Docker file, set two variables, and then build it. So a tagged latest version is probably what you want most of the time. It depends on the practice, really. As Stefan has said, you need to see how much you have to invest to get something to work. If people need that sort of stability, then obviously you would do a matrix build and be diligent about the versions. Okay. So from those people who have submitted their queries initially, can I get some feedback as to whether I've covered this or what else you would like to see, so I can update my project in a way that it gives you what you would want instead?
So from the point of view, I was the one that talked about the pain points or that you have with Epsilon, and it was very helpful to have that wiki page. Thank you very much.
Okay. And the people who wanted the integration with the various tool platforms, could I hear from them? Is that covered reasonably? I don't know who said it because the poll was anonymous. So there was integration with Sirius and Eclipse, other Eclipse tools. Maybe the people have left. Okay. Good. Thank you. I think I would conclude at this point. If anybody has any more specific questions, I'm happy to answer them now. But other than that, there's not very much more to see in this location. I'm hoping to give a much more detailed documentation with many more use cases to this in the future, and we'll see how I can develop this. As I said, one of the next target projects that I have is with Oracle Labs about the security and provenance, and I hope that that is something that opens up an avenue to use this within a research lab, which I think would be really beneficial.